This is question 9. So according to this diagram, we have one device called a manometer. So and this manometer is attached to a pipe. So inside this pipe we have a water flow from left to the right. So and then we need to put an extra device we call as an orifice. So this is called an orifice because to change the velocity of fluid. So now the cross-sectional area here is small, so means that the velocity is higher. So when the velocity is higher here, the pressure on this area is become lower. So and then because pressure at this region is lower, so this oil could move until this level. So I hope you could understand how to draw a manometer. So based on the idea of velocity and pressure. So and then the difference of this height is 32 minus 10 mm. So it is only 22 millimeter. So the question is, we need to calculate what is the pressure difference between point A and point B here. So according to this diagram, we could calculate this diagram, and then we could draw a line here. So and then we could measure that it is this is point C, for example. So and then this is point D. So and then according to Pascal paradox line, we could say that PC is equal to PD. And then we could calculate the pressure for C and D as shown this one, as shown here. So PC is equal to rho G H of this height. Let's say this height is equal to D. So and then it is must be add to the pressure of this height. So let's say this height is Z, and we add with the pressure of point A. So and then for point D here, so we could calculate the pressure of point D. It is equal to rho GH of this one, so which is equal to D. And then the rho GH of water, which is equal to Z here. So and then the pressure of point B, so as shown here. So and then we could calculate the PA minus PB because we already have three equations here. So from these three equations, we could say that PA minus PB, it is equal of this one. We substitute all the value, and then we could get the pressure difference between point A and B. It is equal to 21.6 Pascal.